of STEM innovation. Continuing this part 2 conversation on increasing and decreasing functions. We're going to be looking at those functions again, because there are 3 that we can increase, we can decrease, but what I also wanted to mention was that we could have functions that are, in this case, like a piecewise, where we have linear pieces that are put together, but we have a constant. It's not increasing nor is it decreasing from this portion to that portion, from whatever that value is, negative infinity, all the way to 0. It's increasing. From 0 to 2, it's constant. From 2 to positive infinity, it's decreasing. So we can communicate that, and I just wanted to mention that part 2 portion of increasing and decreasing. In addition to that, we're going to be looking today at finding relative minima and maxima values in our functions. So we're going to be looking at the relative minimum and maximums. Well, what that means to the picture of a graph is really pretty simple. And as I adjust over here to this picture, we're really going to be looking at, hey, where are the mountain peaks and where are the valleys in a specific interval of domain. So here you see you've got 2 different valleys. But if somebody says, hey, what's the minimum? Well, you've got more than one minimum point. So the relative minimum means we're going to look in this interval of domain to determine what that relative minimum is going to be. Minima is plural for minimum. Maxima is plural for maximum. And so we're going to look at those locals. Now, there's a couple of things that we're going to do today. We're going to show there's a graphing calculator method that you need to get in class, and how to use that to find the minimum and max. But when we get to our examples, we're going to look at how we want to estimate what that is using the graphing calculators. And so as we type in this function that we have here, 3x squared minus 4x minus 2, if you'll go into the function mode and type that into the y equal mode, and type in your function into the graphing calculator, once you get into that graphing calculator to find max min, you can simply graph, hit the graph key. Make sure you see a good picture of the graph that your window's set. So you want to graph that to find the min and max. You want to graph once you get it typed into the y equal. Make sure you get a good picture of it. And then you can simply hit the trace key. Now, I don't have a calculator in front of me, or maybe I do. Let's see, I do. Yeah, the trace key you find in the 410 position. So once you type that trace key, you'll see a blinking alien in there and on that graph, and you can then move with your cursor left and right and get to that mountaintop to get that relative max, or get to that valley point to get that relative minima, to be able to estimate what the coordinate. That's one way. That's one way. And actually that doesn't get really accurate. A more accurate way with the calculator is, once you've got the graph up there, you can hit the second key, which is either blue or yellow, the second key, and then trace. And that'll take you to the calc, where you see a menu screen that one of those menu offerings will either be maxima, max, or min. And then it's going to ask you a series of questions of getting to the left, left bound, getting to the right, right bound, and then guessing. And it'll tell you more accurately at the bottom of the screen what the coordinates are, what the x coordinate is, and what the y coordinate is for the max or min. I'm looking at the coordinate for this function that we were looking at just a second ago. in example 5, that'll tell you the coordinate for, in that case, in example 5, the relative, in this case it was a minimum for that function. That's the coordinate for that lowest value in that region of the domain. So that's what relative minimum and maximum is. Well, you know, this is pre-calc, and we are cooking a lot along here as we look at various things and functions as we're analyzing in this entire section, analyzing functions. We are